All right, let's get started. So you guys, in order for us to learn about the quadratic function or to review the quadratic function, I think it's important just to compare what the line is and what a quadratic is. So this also serves as a good review of what we learned on Friday. Let's go ahead and try to graph this line using the table of values and then also graphing it on the actual grid. This equation is pretty easy because it doesn't have much going on. It's just y is equal to x. So that means every yx value is the same as the y values that came before it or that are paired with it. And then graphing it looks like that. Make sure you guys grab a ruler or a straight edge. Connect all the dots, put arrows on both ends, and then also label this with the equation. Stalled enough. Let's talk about something called first differences. First differences are just the differences in your y values. And you're basically just looking at these numbers and you're looking at how much they are differing. So I usually just subtract the first number from the second number. This is -1. This is -1. And then this is 1. You know what? We don't even have to look at the positives and negatives. Let's just see how much they're going up by. So this is 1 and 1 and 1 and 1. And you're going to notice for any line or any linear function, the first differences are always going to be the same. Okay, let's do this exact same thing, but this time we're going to look at a quadratic, and the quadratic that we all know is the parabola, which is y is equal to x squared. So what I'm going to do is I'm going to put in all those x values into the equation, and I'm going to solve. So it's going to be 9 and 4, 1, 0, 1, 4, and 9. And then just graph them as well. First, I will just label this. This is a parabola. And that's the only quadratic you know. We are going to learn more functions in grade 11, but for now, that's all we know. If we just take a look at the difference between the numbers, we have 5 and 3 and 1, and then 1 and 3 and 5. And you notice the first differences are all different. And so this leads us to a general rule that whenever your first differences are the same, it is a linear function. And whenever the first differences are different, it's a quadratic function. You can also figure out if something is linear or quadratic based on the equation. So if you take a look at this box over here, it says a linear function, both variables are first degree. And that's just a fancy way of saying both of the exponents on the variables are 1. So if y is equal to 2x plus 5, it's going to be y to the power of 1 and x to the power of 1. So anytime both of the exponents are a 1, you know that is a linear function. For a quadratic function, the x is going to be second degree, which means the exponent will be a 2, and the y is going to be first degree. So if you ever end up with something like y is equal to x squared minus 3, this is an example of a quadratic equation because there is an exponent of 2 on top of the x. So if I give you a list of equations and ask you what is linear, what is quadratic, you're basically just looking at the exponent on the x to determine that. And then a graph is really straightforward. A linear graph is a straight line. A quadratic function is, for now, just a parabola. Does this sound familiar? Okay. Let's look at the parts of a parabola. So these are all words you guys probably remember from grade 10. We're going to go through them. A vertex is the highest or lowest part of a parabola. It's basically where it starts to change the direction. And to label that on a graph, you just read the coordinates, and that's what you would get. The y-intercept, just like the line, a y-intercept is wherever the parabola is going through the y-axis. And so you can read it off the graph, but if you're trying to find it algebraically, you're going to let x equal to 0 here and solve. For x-intercepts, again, it's this and this. It's wherever the parabola is going through the x-axis, and it's going to be, we're going to let y equal to 0 to solve it, or you can just read it off the graph. The axis of symmetry is a parabola is perfectly symmetrical. So if you want to split the parabola in half, that is what is the axis of symmetry. To do that, you can just split the parabola in half by drawing a line and then figuring out what the equation of that line is. Basically, what number does it go through and what axis it's going through. So in this example, it would be x is equal to 1. And then a parabola, because it can open upwards or downwards, the vertex can either be as high as possible, making it a maximum, or it can be as low as possible, making it a minimum. Any questions about any of these words? Yep. Sorry, Sarah first. Yes, there is. With an equation, there is one, and when we get to the equations, we will. Arzu? How do you find the vertex from an equation? Yes, so we'll get into that as well. Okay, the next sheet is just all of these words all put together. So again, you may see the word 0 sometimes, but it still refers to the x-intercepts, y-intercepts, vertex, and axis of symmetry. And all of those are, the answers for those are listed at the bottom. Now here's a question for you. How many x-intercepts does a parabola have? Yep, 2 or, yep, or 0, yeah. So let's actually look at that. How come a parabola can have 0, 1, or 2 x-intercepts? Well, it can have 0 x-intercepts if it is one of those floating parabolas and it's kind of just floating around. The vertex is here and it's pointing upwards or downwards. It could have 1 x-intercept. I call these the parabolas that are sitting. So if it's just sitting somewhere on the x-axis, then it only has 1 x-intercept. And a parabola can have 2 x-intercepts if it's actually going through the x-axis, and that way it would have 2. How many y-intercepts can a parabola have? Nice try, but no, yeah. Just 1. A parabola has to have 1 y-intercept because no matter where you started, even if you like draw it over here, eventually it's going to keep going until it does hit the y-axis. So every parabola must have 1 y-intercept, but the x-intercept, it could vary. Question? Trying to check to see if he's there and he's not. Okay, so based on this knowledge, let's try and answer some of these questions. It says, how many times can a parabola cross the x-axis? We already did that. Draw a rough sketch of a parabola which opens down. And I always call it, like if it opens up, it looks like the letter U. If it opens down, it looks like the letter N. So it opens down and it has a vertex anywhere in quadrant 1. To answer this question, we first need to know how to label our quadrants. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Oh, you guys can't see that. That's better. And so our parabola, if it is starting in quadrant, anywhere in quadrant 1 and it's opening downwards, it would look something like this, and it would have 2 x-intercepts. So 1 over here and 1 over here. Question number 2 says, draw a rough sketch of a parabola that intersects the x-axis only once. There are literally an infinite number of solutions for this. You can draw your parabola anywhere as long as it's quote unquote sitting on the x-axis. And in this case, it would only have 1 x-intercept. And then for question 3, draw a rough sketch of a parabola that does not intersect the x-axis at all. I call these the floating parabolas. And again, you can draw them anywhere you want, as long as it doesn't go close to the x-axis. And in this case, it has 0 x-intercepts. So 2, 1, and 0. So how does that apply? Fun part. All right, so the majority of your grade 10 course for this unit was spent graphing a parabola. We're going to go through all the transformations because remember, a parabola isn't just sitting there. It can move to the right or to the left. It can go up or down. It could flip around. So we will fairly quickly review all the transformations because, like I said, this is a concept you've learned before. We start with y is equal to x squared because this is what we call our parent, this is what we call our parent function. So that just means like it's the original parabola, what every other parabola is sort of compared to. Remember how on page 1 we drew our table of values and then we filled it out? That's a really inefficient, we introduced it that way, but it's a very inefficient way to graph a parabola. We need a quicker way to do this so that we don't waste time. And this is where our step pattern comes into play. So our step pattern for a parabola is you always start at the vertex, which in the parent function is 0, 0. And then you're going to use the numbers 1, 3, and 5. And it's demonstrated on the left graph. So you're going to go 1 to the right, up 1, 1 to the right, up 3, 1 to the right, up 5. And you do the same thing on the left-hand side. And this is how we're going to graph all of our parabolas henceforth. So let's go ahead and try to graph y is equal to x squared ourselves, because it's already done, but we need to practice. We're going to start at 0, 0, which is the original vertex for the parent function. We're going to go 1 to the right, up 1. Then we're going to go 1 to the right, up 3. And then we're going to go 1 to the right, up 5. So 1, 3, 5. You're going to do the same thing on the left-hand side. Do we need to use a ruler to graph a parabola? No, in fact, it should not be rigid lines. It needs to be a nice smooth curve. Which I struggle with on this. Like you want to make sure you have arrows on both ends, and we're still going to be labeling all of our graphs. So y is equal to x squared. Okay, now what we're going to do is with this parent function, we're going to do all sorts of stuff. We're going to move it up and down, side to side, etc. And to do that, we need to break down all of the different transformations. So if you take a look at this chart over here, it tells you all of the different transformations you learn in grade 10. And I have kind of a way to remember all of these different things. So the way I think about it is everything outside of the bracket. So see how x minus h is in a bracket? Everything outside of the bracket is going to affect our vertical. So all of these are going to result in some sort of vertical transformation. And then everything inside of the bracket is going to affect our horizontal. Okay, but we're going to do it one thing at a time. So the first transformation we're going to begin with is the number that is at the very, very end, the constant. In this case, it's called the k value. And that is going to represent our vertical translation. So it basically tells you how much your parabola is moving up or down, and you will find that number written after your x squared. So it's going to require a little bit of flipping back and forth, but let's go to these two questions that are the vertical translation questions. Okay, I have two examples here, and if we just take a look at it, we're going to have a number in front of the x squared. Guys, I have to just start this again because it's... Okay, so in this example, we're looking at everything outside of the x squared. So here we have a -4, here we have a +2. A -4 means our parabola is going to go down 4 units, which means if it was originally supposed to start at 0, 0 and we're moving it down 4 units, what's the new vertex going to be? 0? Good. 0, -4. That's our starting point. And now to graph it, we're going to use our 1, 3, 5 step pattern. So we're going to go 1 to the right, up 1, 1 to the right, up 3, 1 to the right, up 5. And we'll do the same thing on the left-hand side. And the way we would describe this in words using proper math language is it's a vertical translation 4 units down. The next one is y is equal to x squared plus 2. And I know you're probably working at your own pace, so you just keep going and I'll pause after this example. For this parabola, if it's plus 2, which way are we going? Are we going up or down? Yeah, we're moving up, which means our vertex is going to be at 0, 2. And then from there, we're going to do our step pattern. So 1 to the right, up 1, 1 to the right, up 3, 2, 3, 4, 5, 1 to the right, up 5. 2, 3, 4, 5. Okay, good. You're going to connect all the points, make a smooth curve, arrows on both ends, and then label your parabola. And using math language, this is a vertical translation 2 units up. Let's keep going. All right, going back to, so we did that. Going back to our graph, our chart over here, let's talk about what the sign in front of the equation means. If you have a sign that is positive, it means your parabola is going to open up and it's going to look like that. If the sign is negative, it means your parabola is going to open down and it's going to look like that. And the official words is it's a vertical reflection in the x-axis. So to describe it, we would say vertical reflection in the x-axis. What does this mean when we're actually graphing our graph? Well, all we're going to be doing is we're still going to start at 0, 0 for our vertex because there is no shift to the side or up or down. But now instead of going 1 to the right, up 1, we're just going to go 1 to the right, down 1. So 1 to the right, down 1, 1 to the right, down 3, 1 to the right, down 5, and then do the same thing on the left-hand side. And that's a vertical reflection in the x-axis. All right, we're going back to our chart now. We're finally ready to look inside of the bracket. We kind of already talked about it. We know it has to be a horizontal translation. And what that means is this number inside of the bracket is going to be shifting our graph to the right or to the left. Now, it's a little counterintuitive because even though it's moving to the right or to the left, the sign of the number matters. If the number inside of your bracket is positive, that's actually going to be shifting your graph to the left. And if the number inside of the bracket is negative, that's actually going to be shifting your graph to the right. Yes. Yeah. After you clean up all the signs, the final number, that's what you're going to think of when you do your rules. All right, so let's try 2 examples with these rules. Horizontal translation. I know it's a horizontal translation because I see something in the bracket. This is x minus 1 here. This is x plus 2. By the way, I know you're not going to make this mistake, but a mistake in grade 10 is when someone sees a question like this and then they expand it and FOIL it and stuff like that. Don't do that. This is the proper form that it's supposed to be in when you're graphing a parabola. So if you take a look at the first one, what do you guys think should be our vertex? If it's a negative 1 inside the bracket, which way are we going to be going? 1 unit to the right. So, and our vertex is going to be 1, 0. The way we would describe that is we would say a horizontal translation 1 unit to the right, and now we just use our regular step pattern. 3 and 5, 1, 3 and 5. Okay, while you're working on that, I'll just go over to the second example. X plus 2, if the number is plus 2, which way are we going? To the left, which means our vertex is going to be negative 2, 0. The way we describe that is it's a horizontal translation 2 units to the left, and then we just use our 1, 3, and 5 step pattern. actually. All right, going back to our chart, we're ready for our last transformation. And this one tends to be the hardest, although it's, it's not. Okay, we'll just go over it. Whenever you have a number in front of the bracket, so see this little a over here, that number is really important because it tells you how much your parabola is stretching or compressing. And here's how I explain it. Here's how I describe it. Imagine that you're holding a balloon from the top and the bottom. If you were to take that balloon and you were to stretch it, does it become narrower or wider? Narrower. And if you were to compress it, does it become narrower or wider? Wider. And the exact same thing happens with our parabola. So when we're talking about a parabola stretching, that means that parabola is going to become more narrow. And whenever we talk about a parabola compressing, that means our parabola is becoming wider. Now, how do we figure out if it's wider or a stretch or a compression? You have to look at the number in front of the x squared. If the number is greater than 1, so 1, 2, 3, 4, 5, that is going to be a stretch. If the number is between 0 and 1, most often a fraction between 0 and 1, so like a half, a third, a quarter, whatever, any other fraction, then that would be a compression. So that is a lot to remember, but just keep those things in mind. Always remember the balloon example, and then you will be able to remember this. And what is it narrower and wider to? Like, what are we comparing it to? We're always comparing it to the parent function y is equal to x squared. So that's always our frame of reference. Okay, so to make this question. Yes, between 0 and 1. Like a negative? Well, I look at the positive and negative differently because the negative just tells me if it's, yes. Okay, so let's do these examples. Go to the section that says vertical stretch. All of the stuff I just said is actually repeated over here. So if your A value is greater than 1, it is a vertical stretch and your graph is going to be narrower. All that's done. It's also demonstrated for you as an example over there. Okay, but most importantly, how exactly am I going to graph y is equal to 2x squared? I know the vertex is going to be 0, 0 because the graph hasn't moved side to side or up and down. There's no other number. What I'm going to do to graph this is, remember our step pattern 1, 3, and 5? We're going to take those numbers and we're going to multiply it by whatever number is in front of the x squared. So I'm going to multiply this by 2. I'm going to multiply this by 2, and I'll multiply this by 2. If the number was a 3, you would multiply all of it by 3. If it was a 7, you'd multiply it by 7. And the numbers you get when you do the multiplication is your brand new step pattern for this question. So what this means is now starting at 0, 0, we're going to go 1 to the right, but we're going to move up 2 this time. And we're going to go 1 to the left, and we're going to move up 2. We're going to go 1 to the right and move up 6. 1, 2, 3, 4, 5, 6. We'll do the same thing on the other side. And if you have enough grid paper for 10, you could have done that. In this case, we can't fit that. So that's all we really need. I'll only ever ask you for 5 points. And so this is our graph for y is equal to 2x squared. And if I were to graph y is equal to x squared on the same grid, I would notice y is equal to 2x squared is narrower than y is equal to x squared. Bea? Okay, for the compression, everything we had discussed before, again, is noted all right here. So if the number is between 0 and 1, also known as a fraction, that's going to be a vertical compression. It's going to result in a wider graph. Our equation here is y is equal to half x squared. We're going to begin at 0, 0 because there is no vertical or horizontal translation. And we're doing the same thing we did before. We're going to start with our step pattern of 1, 3, and 5. And we're going to multiply all of those by a half. 1 times a half is a half. 3 times a half is 3/2, but I'm going to write it as a mixed fraction. 3/2 is the same as 1.5. 5 times a half, half of 5, another way to think about it, is 2.5. Okay, you have to be really careful with the halves because you are estimating. Just try to be as accurate as possible. Starting from 0, 0, you're going to go 1 to the right, up a half, 1 to the left, up a half. Then I'm going to zoom in here so you guys can all see. Okay, then I'm going to go 1 to the right, up 1.5, 1 to the left, up 1.5, 1 to the right, up 2.5, 1 to the left, up 2.5. Now, while I can give you any fraction to just calculate with, when I'm graphing, I'm only going to give you easy ones. Like I would never give you a quarter or 3/4. Those are too hard to graph. So usually for graphing, we stick to halves. Okay, so now I'm just going to zoom out so I can put it all together. Lost it. There we go. So make a smooth line. And this one, it's like super obvious how wide this graph actually is, which means we've done it correctly. This is y is equal to a half x squared. The way you would describe this, by the way, is a vertical compression by a factor of 2. And the previous example was a vertical stretch by a factor of 2. Questions about this? Okay, we're going to put everything together now because obviously you're not going to get questions that are split up like that. The next 2 examples are more what you're going to be seeing. I'm going to scroll up, even though I see a few people writing. Let's go ahead and try these ones. Okay, so how do I approach a question that has literally every single transformation? The very first thing I try to figure out is the vertex. So I know a parent function starts at 0, 0. This graph is moving 5 units to the right, and it's also going up 9 units. So where does that land my vertex? Close. Good guesses, Sarah? Yeah, it's going to be 5, 9, because remember it's starting from 0, 0, you're moving 5 to the right and then up 9. This negative tells me my parabola is opening downwards, so it's just telling me the shape of it. And then that 2 is super important because it's telling me I have to take my step pattern 1, 3, and 5 and multiply every single number by 2. You don't have to write this down. You could just do it in your head. But sometimes, especially when you're like stressed for time or it's an assessment, it just makes it's easier to write it down. Well, oh, I'm sorry. That's better. Okay, so from 5, 9, I am going to go 1 to the right, down 2, 1 to the left, down 2, 1 to the right, down 6, 1, 2, 3, 4, 5, 6, 1 to the right, down 6. And I can actually fit 10 because there's enough space here, so I'm going to put in 10 too. And then you're just going to label it somewhere. I like graphing because I can finally use all the colors you can never see when I'm writing like algebra stuff, but at least with a graph, you can kind of make out the shape. All right, let's try this next example. Y is equal to a half x plus 4 minus 8. So for this question, I can see that my parabola is going to move 4 units to the left and down 8 units. So where is my vertex going to be? Not all at once now. My vertex is going to be at -4, -8. Does this parabola open upwards or downwards? Yep. And we know this because the number in the front over here is a positive. If it's a plus, that means it's going to be moving up like this. And the half tells me that this is a vertical compression by a factor of a half. Our graph is going to be pretty wide. And we just did this calculation above. So we're going to take 1, 3, and 5 and multiply everything by a half. So you're just trying to figure out what half of these numbers are. Half of 1 is half of 3 is 1.5, and half of 5 is 2.5. I'll zoom in again while I do this so you guys can see exactly where my points are. So I start at -4, -8. I move 1 to the right up a half, 1 to the left up a half, 1 to the right up 1.5, same on the other side, and then 1 to the right up 2.5 and 2.5. Okay, and then you're just going to graph everything and label this. Now, one thing I just want to talk about while we're on this question, because we haven't really done it in the other ones, is how do you figure out the axis of symmetry from a graph? Well, I just look at wherever the vertex is, because that's sort of the midpoint of my graph. And I would just draw a dashed line going down. And to figure out the equation, like what this line is, it's going through the x-axis at the number -4. So that is what my axis of symmetry would be. X is equal to -4. Tanisha? How do you figure out all of this information without actually having to graph it? So just for this example, let's pretend we didn't have the graph for it. We're just going to use the equation and determine all of these features. And I only show this because I think it's cool, like it's faster and more efficient. To figure out the vertex straight from an equation, you're going to look at this number and change the sign. So if it's a +5, you're going to put down a -5. And then you look at this number and write it exactly as is. So it's just going to be a 6. So your vertex is going to be -5, 6. And of course, if you don't remember these, that's fine. You can just sketch it out and read it off the graph. That's always an option. Does the parabola open up or down? For that, you're going to look at the sign in the front. If it's a negative, we know it's going to be opening down. Step pattern, what you would do is you take 1, 3, and 5 and multiply it by that fraction. Because we've done it so many times, we don't even need to really show any work. We know it's going to be 1.5, sorry, half, 1.5, and 2.5. Axis of symmetry. So we just showed it in that example, but what's a quick way to figure out the axis of symmetry? Noel? Yes, exactly. So you're going to take whatever is inside the bracket and just take the opposite. So it would be x is equal to -5. If it was a negative number, it would just be the positive. So it'd be x is equal to -5. Okay, maximum, is it a maximum or minimum? Well, for that, you can just think about if it opens up or down. If it's opening down, the vertex is as high as possible. So it's definitely going to be a maximum. And if we're trying to figure out where does it occur, like where on the y-axis is this vertex hitting? So I'll just explain that using this. To figure out where the value is, you just take this and you go to the side and read off the number on the y-axis. To figure it out without a graph, you just look at this number over here, and it tells you the maximum is going to occur at y is equal to 6. So the highest point of this parabola is going to be y is equal to 6, and then everything will be below it. Okay, for the y-intercept, if you're graphing it and you can read it off the graph, perfect. That's your point. But if you're looking at an equation and trying to figure it out, you're going to let x equal to 0 and you're going to solve. So this is going to be a little bit of algebra work. I'll show it to you over here. So it's going to be y is equal to -1/2 bracket 0 plus 5 squared plus 6. And you just solve. So it's going to be -1/2 times 25 plus 6. This is going to be -25 over 2 plus, I'll just find a common denominator of 6, which is 12 over 2. And this would be -13 over 2. If you want, you can change it to a mixed fraction. So this would be -6 1/2. That means this y-intercept would be at 0, -6.5. So you can figure it out by looking at the graph, but sometimes it's not super obvious from a graph, so you always have algebra to figure it out with. Tanisha? I only do that because it makes graphing easier. So now that I know this information, I know my y-intercept is going to be right over there. Then improper. Yeah, yes, definitely. Marzouk? No. If we're not doing anything with it, then it doesn't really matter. And then finally, for the x-intercept, we're just going to be reading it off the graph. In the next unit, we will figure out how to figure it out algebraically. But for now, you're going to read it off the graph. Sometimes it will be whole numbers. Sometimes it might be decimals. You're just going to estimate to the best of your ability. And that's what you're going to do. Okay, that's it for me. Let me tell you guys your homework. And for you guys online, I'm going to pause at the end at every page so you can take a look at it. You have, actually, if you have your grade 10 notes, this is exactly what you got in grade 10 anyways, maybe formatted a little differently. So for every single question, you're going to be drawing the graph and then you're going to answer the chart. So question 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have all the solutions of the graphs at the end, and I also have all of the chart at the end as well. It is a lot of work, but please make sure you do it for homework so that you are well prepared for our class tomorrow.